Okay, we can start
Okay, I
soon.
can start. Yeah. So good evening. My name is Dr. Shakti, and we're going to be continuing with your hematology classes. So we already covered a bit of your erythropoiesis, then we went to WBC. Today we'll be talking about blood group. Okay. Um, so in blood group, it comes as a short note. Multiple different short notes can come from blood group topic. Another thing is this topic is also important for your practicals, where under hematology it will come as a short question. But you need to understand the topic really thoroughly to be able to answer few questions. Okay, so that is where I'm going to help you understand all of this. Um, yeah. So let me just start off with one question. Okay. So the A antigen is made by the addition of dash into H antigen. So the answers can be NSTL, galactosamine, L-fucose, galactose, none of the above. So in order to answer this, you need to understand what the structure is. Two, what exactly H antigen is. Okay. And what are the different ways by which ABO blood group is formed. So the answer for this is your galactose. Before we come to this, we'll try to understand a little bit about the topic. So when we're talking about blood group per se, so we have the blood vessel, blood is flowing through it, and we put RBC, and corresponding to this, I'm just putting another blood vessel. This is a different human being, and that person is also having an RBC. So on the RBC membrane, any membrane for that matter, majority of the component of your share of your membrane is going to be a protein. So you take a protein which is there on top of your membrane. To this protein, you add a bunch of oligosaccharides. What does it form actually? Major chunk of it is a protein to which oligosaccharides are added. So it becomes a glycoprotein in that regard. So these blood groups, are nothing but, glycoproteins which are present on the membrane. So definition, what is uh, a blood group? The thing is, when I was in PG, one examiner suddenly asked me, what exactly is a blood group? And I had no words to answer. So similar questions I've seen examiners asking students also for the Viva for the final exam. And a lot of times I've seen that students are unable to answer to that question. So what exactly is a blood group? What does it mean? It is based on the classification based on the differences between the presence of different glycoproteins which are present on top of the RBC membrane. That is essentially what the blood group classification is. Okay. So imagine this one has a particular type of antigen which is there. Okay. Now another person, on the other hand, has a completely different one. So we have two people here with the RBCs having two separate antigens. So this is one thing that we have to start with. What all are we going to discuss today? One, antigen. Peculiarity of what is antigen, how it is made. Okay. Next thing, we have to understand what is the antibody corresponding to it. And then we have to understand how the interaction between them is going to happen, especially for things like transfusion. Why is this whole understanding of blood group system important? Because as doctors or future doctors, you're going to be dealing with blood a lot in different scenarios. Okay, you'll have to give blood transfusion, you'll have to treat patients in many various ways. So in that regard, you have to understand a lot of concepts about your blood group system. Okay, so as I was telling, one person has a particular antigen present on them. Now, if an antigen is there, okay, imagine there is a antibody which is supposed to be against this antigen. In this scenario, if this was supposed to be the antibody, this would not exist like this because this is a self antigen. So if, for example, this has been living, this RBC with this particular characteristic has been in the person's body since childhood, from birth, before birth actually. Okay. So this is something which innately we know that it is our own self. And we have learned not to create any sort of an immune reaction against your own antigen. Okay. So that is the first thing. The second thing is, if I were to come and put through an injection, through some sort of transfusion, blood from this person and put it here into this RBC. This RBC is now having a separate antigen, which is not present in this person, because of which it is now detected as a foreign object. So against that foreign object, you're quickly gonna generate types of antibodies in order to go and attack this. In a similar fashion, you take the blood from this person and put it over here. Again, the same thing is going to happen. Okay, so otherwise, this person will have antibodies against this. So this is where we have to understand a terminology, which is called Landsteiner's law. So again, this comes as a short note, Landsteiner's law. Landsteiner, because he was the first person who had discovered the presence of ABO as well as RH blood group system. So there are two laws to this you have to understand. Okay, in simple terms, as I was just telling you, if a particular antigen is there, okay, if a particular antigen is there, the corresponding antibody of that is not going to be there. Again, here, if this antigen is there in a person, the corresponding antibody will not be there. Simple as that. The second part of it states that if a antigen is not present, for example, in this person, the blue one is not present here, which means it is not self, and hence the corresponding antibody is present over here. In a similar fashion, in this person, second person, since he does not have orange, then the corresponding antibody is present. Now, again, another thing I have to tell you is this concept of blood group system was discovered way back in 1900, beginning 1900 that time. So at that time, the terminology of antigen antibody was not commonly used, and they didn't actually understand why this was happening or what is the biochemical reaction actually happening over there. So the terminologies included agglutinogen, agglutinin. Okay, this is where I hate it, but it's, your examiners are going to give you help for this. That is why I'm, making you understand this. When you're writing the answer, when you're telling the answer, especially the old examiners and all, they expect you to say these terminologies. Okay, they still live in 1900, but world has moved on. We now have words like antigen, antibody. I tell you, it's not wrong to use that terminologies. So in your head, you can study antigen, antibody, whatever. But for the exam, just for the sake of it, okay, because you have to get marks, you can use the terminology agglutinogen, agglutinin. Okay, what is agglutinogen? Something that stimulates the production of something else to come and agglutinate with it. Okay, so that is this antigen. So instead of antigen, you use the word agglutinogen. And instead of antibody, you use the term agglutinin. Just use these terminologies. Okay, so it's very simple. If an antigen is present on the surface, the corresponding antibody is not there. Or if an antigen is not present, the corresponding antibody is going to be present. Now, this is where you have to understand there is a exception to this rule. And the examples include your RH blood grouping system and your M and S blood grouping system. I'm just going to keep it there. As we go along the way, by the time we reach RH, it'll start making sense. Okay, so we have two Landsteiner's law. Now we'll come specifically into discussing these three headings that we were talking about with regard to ABO blood group system and your RH. These two are not the only blood group systems which are present. Apart from that, you have, Kell, Lutheran, Duffy, MNS, like multiple different types of blood group systems are there. So the most important that we use is this. Okay, so that is why we're gonna be describing ABO and your RH. But in Viva also, they might sometime ask, can you just name a few other blood group system? Okay, you can use Kelly, Lutheran, Duff. Okay, different terminologies like that are there. Now we'll go into your ABO blood group system. The first thing we have to discuss is your antigens in it. So initially, there is a backbone structure that is formed, regardless of what blood group is gonna be there. Okay, so next to that protein we were talking about, to that usually a glucose is attached. To that glucose, you attach a galactose. To that galactose, you attach a N-acetyl galactosamine. N-acetyl galactosamine. That is what I'll give it as NAG. Okay. And then you put another galactose. This is like the backbone structure. So what is it again? Glucose, galactose, N-acetyl galactosamine, galactose. Okay, a glucose, galactose, N-acetyl galactosamine, a galactose. To that, I'm gonna add a particular component which is called L-glucose. Now this is the ultimate base structure onto which further things can be added. So this L-fucose is further added by a particular H gene. Okay, making this entire structure your H antigen. The importance of this I'll be discussing with you shortly. Okay, there is a particular blood group called Bombay blood group. Often asked for the questions. Okay, even MCQs come from this. Anyway, I'll discuss it, but this is the base structure. So we have glucose, galactose, and acetyl galactosamine galactose. To that, you add an L-fucose. This becomes a H antigen. Now, to this H antigen, from your chromosome 9, if for example, over here, you end up adding at this location. Okay, over here like this, you end up adding a galactose, another galactose. Already we have 1, 2. You add another galactose. That becomes your A blood group. Because that person is having that structure is called a A antigen. Instead, if a person in the same location, instead of that, you add another N-acetyl galactosamine. That person's become a blood group which is B because of the presence of B antigen. So we have A antigen, we have B antigen. How can you draw the A antigen? Glucose, galactose, N-acetyl galactosamine, galactose attached to L-fucose. To that you attach one more galactose. Attachment should come here, not here. That becomes a A antigen. Instead, if you add a N-acetyl galactosamine, that becomes a B blood group. Okay. Now, in various combinations, this can exist in different ways. So that is how phenotypically it can be expressed as A blood group, a B blood group, a AB blood group, or O blood group. And I'll just put one more thing here called Bombay. So A blood group is because of the presence of a A antigen. B blood group is because of the presence of B antigen. AB is when both A and B is coexisting in a person. And O blood group is a person who does not have any of these antigens. It doesn't have a galactose, it does not have an extra N-acetyl galactosamine. But the person still has your H antigen. Okay, so no other specific antigen, just the basic H antigen is present. Okay, in a very small proportion of people, especially it was first discovered in Bombay, actually, that's why Bombay blood group. It was noticed that they have a genetic defect where they are not having a fucose which is imparted into that. So the basic H antigen is also not there. Okay, even the H antigen is not there. So even if the person is supposed to be genetically supposed to be A blood group, okay, from chromosome 9, galactosyl transferase is there. But because the H, that basic block is not there, the person will not have the A antigen on top. So it's just like building a house. You build a base first and then you build a house. Now, without building the base, if you start directly building stuff, it'll eventually crumble. Nothing can be put on top. Similar to that, the H antigen is not there. It does not, no matter what genetically the person is supposed to be A blood group or AB or B or O, it doesn't matter. None of it will be there. So it'll look as if the person is O blood group. Just looks as if because no antigen is there. Okay, but that is far from the truth. When you give a blood, for example, O blood to the person, transfusion reactions happen as a result of that. Okay, so again, as I was telling you, we have the ABO blood group system with different types of antigen which you're talking about. Okay, now we'll try to discuss the Landsteiner's law and put it over here to understand certain things. Okay, how antibodies are developing. So actually, the antibodies which are formed here at birth, there are actually no antibodies in the blood. So person is there, okay, this blood has, say, a antigen. His self antibody is not going to be there. This person has never seen a B antigen to start forming an antibody against it. Why would it occur in the person? You understand that this person has never in lifetime understood has never come across a B antigen. Why would a B antibody be here? Normally at birth, it's not there. Then what happens? You start weaning off. 6 months, you start weaning off, and person starts eating other stuff. So actually, between a time period of uh, 2 to 8 months, you get exposed to various stuff, either through the food we eat. Okay, we eat meat for that matter. Okay, so in various ways, or any protein content or something. Uh, so ultimately, you get exposed through your diet, or even just your colonic bacterial flora for that matter. So when you get exposed like that, now the body is like, okay, there's something else from outside which is there, which is a B antigen. It's not us. So now I'll start preparing your antibody against it and keep it. So now this is how after 2 to 8 months it starts. And by the time the person becomes around 10 years, it becomes the maximum titer of antibodies have developed. So this is what you have to understand. So at birth, actually, the person does not innately have an antibody against it. Because of exposure, eventually the person will start developing the antibody against the other ones. So if you look at a person who is A blood group, who has a antigen, this person will have a anti B antibody, will not have anti A because it's self. A person who is a B blood group, he has a B antigen. Now he gets exposed to A antigen and he will have anti A. Now we'll come to AB blood group. Now, a person with AB blood group has both A antigen and B antigen. Okay, he has both A antigen and B antigen. So both are self for him. So they do not usually have any antibodies because they both self. This is only regarding AB blood group I'm talking about. Okay, I'm not complicating things by adding further things. On the other hand, a O blood group has no antigen. So that means the person will have a anti B and will have a anti-A in the blood. What about a person with a Bombay blood group? A person with a Bombay blood group will have anti-A, will have anti-B, will have anti-H also. Because even H antigen is foreign to this person. Okay, you understand what I'm saying? So this is ultimately what is the final outcome you have to understand based on the Landsteiner's law. If a agglutinogen is present, a corresponding agglutinin is absent. If a agglutinogen is absent, the corresponding agglutinin will be present in the plasma. Okay, so these antigens are on top of your RBC membrane. These antibodies will be in the blood. Which part of the blood will be there? The plasma component of the blood. Okay. Now, if we go back to that question, A antigen is made by the addition of dash into H antigen. So again, now you'll be able to answer this question easily. In Bombay blood group, which of the following is true? So again, now it is easy for you to talk about. So absent H antigen is there. B is an answer actually. But that is not the only thing. Because H is not there, A also cannot bind, B also cannot bind. So none of them will be there actually. So that is the better option if you have a choice. Now just descriptive statistics. Okay. So this something you wouldn't know. So in general, in the world, no matter which population you look at, O blood group is always going to be the highest. AB is going to be the least. Okay. So O is always going to be the highest and AB is going to be the least. This is pretty much how it is mostly. Okay. Now in standard textbooks and all, answer A is given as correct because that data is based on data from US and all. Okay, that data is based on data from US actually. Okay, this is just a slight mistake from my part. I put the same option twice. Okay. But in India, this is your answer. O is the highest, second highest is B, then A, last AB. Okay, so first thing, if questions like this come, you look at O, O is going to be the highest. AB will be the least. So automatically you are ruling out the second option. Then AB in that normal order, that is not India. In India, it is BAAB. Okay, so just for your information, that is another thing. So to understand this concept, which of the following is best suited to be a universal donor? To understand this concept of your donors, you need to understand basics of how this law can be put into use. For that, you have to understand two terminologies. Immunogenicity or another antigenicity and immunoreactivity. Two things. So in general, when we talk about this immunogenicity, antigenicity, what you have to understand is some component is brought in. It's a antigen. Okay. How much an antigen will evoke a response in the body? It's a protein. You put a protein from outside, or you take my protein and put it in somebody else's body. So that is not the same thing, it's a foreign object. How much can it elicit that reaction in something else? Okay, so that is basically your immunogenicity. Your body's WBC system and all that complement, all that activation, how much it can elicit it. Antigenicity simply means that you take an antigen and against it, antibody is formed. That. Okay, so they sound similar actually, but slight differences there. But for your level, you just have to understand. You give an antigen and how much it's going to elicit a response. What is the response? Usually an antibody. That is immunogenicity. Okay. Now, this ability of your antibody, which is there, to come and react to this. That is essentially immunoreactivity. Two things. We're talking about this because in the above examples, we were talking about a antigen and an antibody. Okay, this is a very important thing that we're discussing here. Okay, now we take the blood. I'm going to take the blood of a A blood group. The person with a A blood group will have a A antigen. And according to Lansing's second law, this person will have anti-B in him. Now from outside, I'm going to come and put blood from another person who is B blood group. Now you have to understand when you give blood, that blood is minimal actually compared to the full blood of the person. You're giving maybe 500, okay, ml out of your 5 liter of blood. 300 to 500 ml, that is the maximum you're going to give at a time. Okay, so that amount is very little as compared to your entire body's blood. Now, another thing, when you're giving blood, if you're giving a part of the plasma also along with it, then the antibodies are also going to come, which means if you just gave a B blood group to a blood group person, in that plasma, we have the anti-A also. So in this scenario, two things can happen. Because a antigen from outside came, that will result in immunogenicity, antigenicity, resulting in more antibodies to be formed, which will come bind to this, result in antigen antibody complex. Now other cells will come, start attacking it because it's foreign, and the whole inflammatory process will start, resulting in transfusion reaction. Okay, that RBC will get ruptured and all. So that is one thing that can happen. That is because of this immunogenicity that we're talking about, the ability to elicit. And on the other hand, this anti-A, which is also there, can go and bind to the RBCs which is there in that person and destroy it. Which is more severe, which is more important, if you ask me? It is going to be this. Because when you give blood from outside, just 300 ml, 500 ml, in that there is a limited number of antibodies. Once they use up those antibodies and destroy all the RBCs, okay, they're not going to destroy all your 4.5 million RBCs. Few of them will get destroyed, of course. Some reaction might happen, but eventually it'll die away because the blood is over. All the antibodies are used up. So that is a minor problem. What is a minor problem? This is the donor. And this blood is that of the recipient. So a donor who is giving blood, okay, the antibodies which is there inside the donor is a minor problem. But antigen which is there in a donor, that as long as that antigen is existing in the foreign person's blood, it'll keep on resulting in immunogenicity, which means the inflammation will keep on happening, antibodies will keep on coming in till that is completely removed from the blood. And this activity, immunogenicity, will result in a lot of inflammatory process which will keep on getting worse. So it's actually for the good of the body. But during that time, it can threaten that person's life. Okay, so this is one thing I want you to understand right now. A donor who's giving blood, his antigen is very important. Antibody is also important, as I told you, it still causes reaction. But it will be a minor problem. But this will be a major problem. So one question is usually asked. We do something called cross matching. Cross matching. So what do? We take your antigen from your donor before giving the blood. You take the antigen from that person. Okay, put it in a dish. Now you take the blood. Out of the blood, which part has the antibodies in it? Plasma. You take the plasma and put it together in a dish and see if agglutination is happening, reaction is happening. This is what we call major cross matching. The antigen of the donor, that is the problem. So that is what we have to consider importantly. That is why it's called major cross matching. But again, this is also a problem to a degree where antibodies are involved. So that is donor's antibody. So you take now the donor's antibody and mix it with the antigen of the recipient. That is going to be minor cross matching. This again is a short note. They'll ask you what is cross matching, what is minor and major cross matching. You have to explain this. And which is more important? Major cross matching. Why? Because immunogenicity, antigenicity, because of that, the antigen of the donor is much more important. Even if the donor has antibodies, that will eventually disappear. Okay, there's a limit to which it can cause problems because of the dilution effect that is happening. Okay, so I hope you understood this. Now, based on this, again, another set of questions are going to come where they'll ask you, if you're A blood group, who can you give blood group to? Who can you receive blood from? If you're B blood group, if you're O blood group, like that questions will keep on coming. So exams usually for Viva and all, they'll ask you first, what is your blood group? Say you're AB positive. Okay, who can you give blood group to? And who can you take blood? This is actually, as a doctor, also very important for you. Sometimes the blood that the direct ones for a person with A might not be there. Instead, if A is not there, can you use something else? Okay, so this is where you need to understand this. So, very simple. If a person with A blood group, just have to remember, a person with A blood group has what antigen? A antigen. And has what antibody? Anti-A. B. Okay. Now this person can give the blood to another person who's A, because that person is also having A antigen and a anti-B. So neither of these anti-Bs is going to react to any B antigen. And none of the A antigen is going to result in immunogenicity because it is self for each of them. Now take a look at AB blood group. AB blood group has A antigen, has B antigen. Do they have any antibodies? They have no antibodies. So if we give a blood from A blood group to a AB blood group person, is it okay? So A antigen is there. So whatever A antigen is there, this person is also having A antigen. That is not an issue. It will be treated as self. Okay, so that is not an issue. You can give the blood. But you have to remember this AB blood group has a B antigen also. And your A blood group has anti-B in it, which could create a problem. So this is where you do minor cross-matching. Okay, so as long as the titer of this anti-B is less, you can give it to AB blood group. But if the titer of that is high, that it creates a problem, then you do not give it. You understand what I'm saying? So who can a person with A blood group give blood to? You can give it to another person who is A blood group. You can also give it to another person who is AB blood group, as long as the titer of the anti-B is less. Okay. Now, in a similar fashion, the same A blood group, if he requires a blood, he can again take it from your A blood group. Can he take it from your AB? Because there is an antigen which is not present in this person. If you took it from him, suddenly that will result in immunogenicity and a lot of reactions will happen. So you cannot take it from a AB. You can only give it to AB. Instead, who can you take from? This is where you have to think. If you want to take it from somebody, antigen is the major problem. If there is a person who does not have any antigens, who is that O blood group? A O blood group does not have antigens. Okay, so you can take it from a O blood group who does not have any antigen. But you just have to keep in mind that the person has anti-A and anti-B. Just keep that in mind. Because since this has A antigen, you have to look at the titer of your anti-A. Because A is taking it. Instead, if B was taking it from O, you'll have to look at the titer of anti-B. I hope you're getting what I'm saying. Okay, so just this might sound confusing to somebody who's listening it for the first time, but think about each combination of blood groups like that. So always for that, think that having antigen is a major problem in the donor. Okay, so not having antigen is a good thing for a donor. Okay, somebody who has a lot of antigens in them. Okay, so somebody who has a lot of antigens will be able to accept things from others better. Because all of them which you're taking from others will be self. So antibodies won't be there in their body. So this is one thing you have to understand first. Okay, so even without explaining RH blood group system, based on this principle, you will be able to answer this question. Which of the following is best suited to be universal donor? A, B, and O. Only two options are here right now. You just think AB person, a person who's AB, has antigens. Is he going to be a good donor? No. So first two options are gone. Now we have O blood group. Okay. Now we have a person who is O positive and O negative. O positive means the person has a RH antigen in them. O negative means the person does not have a RH antigen in them. So now you try to think and tell me which would be a better donor. Somebody who does not have any antigens at all. So this is going to be answer. So see, even without going to understand how exactly RH, blood group system is, we are able to answer this question based on the principle I told you. Okay. So before we go to RH, I just want to take the time to recap whatever we done so far. First, we understood the ABO blood group, what is the antigen. Then we went to see how the phenotype is going to be with regard to what is the antigen, what is the antibody. We understood about how the antibodies are formed. Okay, we talked about Landsteiner's law. Then we talked about the principle of immunogenicity, antigenicity, immunoreactivity. Then we talked about cross-matching. What is major cross-matching? What is minor cross-matching? Then with regard to how to answer questions like who can you give blood to, who can you take blood to, who's the donor, who's the recipient. Again, if that question was changed, who is the recipient, universal recipient? The recipient is somebody who has all the antigens actually. So AB positive or AB negative, who will be a better recipient? AB positive. because he has A antigen, B antigen, RH antigen. Because of that, he can actually take all these blood who has all of these antigens. Okay, instead if it was AB negative, say for example, you take blood from somebody and that person is, according to ABO blood group, proper, but RH is positive in that person and this person is negative, that will result in a problem. Okay, so to answer that question of universal recipient, AB positive is better. Okay, now we'll go to your RH system. So RH system was also discovered by your Landsteiner. So what he did was he found a particular set of, apart from ABO blood group, something else was causing agglutination. Okay, so the antigen here is formed from another chromosome, chromosome 1, not chromosome 9. Okay, so this resulted in, around, actually, RH system has around 49 different types of antigens. But to test everything is tedious, very difficult. But it was seen that, especially in Asians, majorly we have your capital C, capital D, capital E, then small c, small d, small e. These are the major antigens which are there in Asians. Okay, just like we said, A antigen, B antigen, like that, we have a capital C, capital D, capital E, and a small c, small d, small e. My bad, small e. These are the various antigens which are there according to RH system. Out of that, the capital D and the small d, that is coming from RHD gene. And from RHCE gene, the rest of them come. Okay. Now, if you look at Asian for that matter, around 99% of Asians have your D gene. 99%, that is a big thing. Caucasians and all is 85%. Still a high number. But Asians, 99.99% is actually your RHD gene. So if you have to test RH, then we usually use anti-D antibodies to test it, because majority of them have your RHD actually. Okay. So we have capital D and small d. So if a person is having a capital D, or a capital D, small d, both of them are going to be RH positive. Only if a person is small d, will they be RH negative in nature. Okay. Here again, at birth, when you're talking about the antibodies, at birth, the person does not have an antibody corresponding to it. Now, this is where we have to draw a slight difference. Remember when we were talking about Landsteiner's law, the second law has exception. One is RH. Okay, so what does that mean? So Landsteiner's first law is, if an antigen is present, corresponding antibody is not there. So if D is present, they do not have the antibody against it. Okay. Second states that if the person is negative, the person will have antibody against them. So in RH blood group, we say it is an exception because even in your adult life, generally, you will not, even a negative person will normally not have the antibodies against the Rh antigen because it has not been exposed. So I told you earlier, in ABO blood group system, through the food we eat and all that, we get exposed through food and the colonic bacteria and all, we get exposed. But such an exposure is not happening in RH actually. Okay, RH blood group system is not that easy to get exposed to unless there's direct blood to blood contact. One example where such a direct blood to blood contact is if, for example, this person previously received a transfusion. A Rh negative person got a previous transfusion from somebody who is Rh positive. Now suddenly it'll start appearing. So at that time, it's still okay. Or some sort of needle stick injury. Imagine a doctor was working, okay, and suturing something. That doctor is Rh negative and doing the surgery on a Rh positive person. While pricking something, accidentally got pricked. A little bit of blood from that other person went into your system. Now they'll start developing antibodies. Okay, any sort of transplants, for example, bone marrow transplant and all that. Apart from this, another scenario is there where if a mother is having a kid. So normally, in the first pregnancy, there's no problem. But at the end of that, when delivery is happening, at that time, there is going to be a mix. So when a second child is going to come, by that point, the antibodies are formed. Okay, so one thing is delivery. It's not only normal delivery. Even if it's some sort of a miscarriage, or for that matter, an ectopic, where some bursting happened and mixing of blood and all happened. So you have to think that, okay, maybe this mother, this is the first child that is being born, but you're starting to see something which is similar to your problem here, transfusion reaction, sort of a problem is happening. Okay, but when you now take history, you realize, okay, person had some ectopic pregnancy before, they had some surgery at that time and all, and now this is happening. So it's not always about having the second child. It's not always like that. Okay, this is also a very important thing you need to take into account. So this is where we'll be talking about your hemolytic disease of newborn. Okay, so if X, for example, a Rh negative mother is there, Rh positive child is born to that mother. Normally it's okay because this person does not have any antibodies in it. Okay, since antibodies are not there in the person, that delivery is okay. But during the delivery, the antibodies are formed here. So now when there is a second child, that second child will start having problems because of the presence of this anti-D. What are the problems that can happen? One, because of the reaction that is happening. Hemolysis will happen. So because of the reaction, hemolysis RBC starts bursting. That is what is called hemolytic disease of newborn. Person will have icterus gravidarum neonatorum. What does that mean? Because a lot of hemolysis happening. One of the byproducts of RBC degradation is bilirubin. So bilirubin will increase when lot of your degradation of RBC is happening. So the kid will look yellowish in color. Okay. One response to hemolysis of RBC is production of new blood cells. So blastosis fetalis. Erythroblastosis fetalis, because you need to produce more RBCs now. Okay, so your immature blood RBC cells are more in the circulation because of that. And the fourth thing called hydrops fetalis can also happen. A third thing called hydrops fetalis can also happen, where there is collection of fluid actually, because hemolysis is happening. Okay, that will result in changes in the volume and all, how much your permeability and all. So ultimately, what is going to be happening? There's going to be a lot of fluid accumulation here and there. So in more than two pockets, when fluid accumulation is there, you call it hydrops fetalis. So all of this together is basically hemolytic disease of the newborn. What is coming under it? Okay, so how can you treat it? One thing you can do is, around 22, 28 weeks of pregnancy, even before delivery, you give anti-D. Okay, it's actually anti against the anti-D actually. And then 72 hours after delivery also you give. Okay, this is actually anti against the anti-D. Then you can also give phototherapy and exchange transfusion. Exchange transfusion, how can you do? Problem is the antigen antibody which is there. You exchange it, take the plasma and replace it with the fresh one, which does not have all of this. Or you can give phototherapy. You put it under blue light like that, and that will help convert the bilirubin to cis bilirubin, which becomes more water soluble. Okay, so just a question again. Complication of hemolytic disease of newborn include all except. So kernicterus, hydrops fetalis, erythroblastosis fetalis, they're all part of it. What exactly is kernicterus? So this, I told you bilirubin is increasing. When bilirubin increases beyond a particular point, and in a child, in a fetus, the blood-brain barrier is not developed. So your bilirubin can cross the blood-brain barrier, go into the brain, resulting in changes. That is kernicterus. Okay, so this will be the option. All except. Which of the following is best suited to be, oh, sorry. This again, just change the question. This is not the question. So which of the following is the treatment for, can be used as a treatment against hemolytic disease of newborn? Okay, the answer is all of the above. You can give prenatal anti-D, you can give phototherapy, you can give exchange transfusion. Okay, so we will just finish it off by understanding about Auricle. So Auricle has previous recorded sessions which are made available at your own convenience. You can go through it. There are live sessions as well, like the one you're attending right now. There is Express exam module where 20 less than 20 hours you can complete the entire syllabus. Just before the exam, you can do this in order to understand what exactly you have to write, what to study, and all that. There is one-to-one doubt clearing sessions in the app, and you can even get a hard copy note sets. And these notes have MCQs, questions, match the following diagrams, various things like that are present. And question bank also has different levels of expertise according to your requirement. You can take it, and it's important not only for your university exam but even beyond that. Practical sessions are also there, and these are the various subscription plans that are available. And you can use my code Dr. Shakthinag 20 for discount on subscription. You can reach out to the members through the various social media handles. So again, thank you for watching. See you again next time.